Hi, Nutrition 101. Welcome to part 2 of Lipids, chapter 5. Today we're going to be talking about digestion, absorption, and metabolism. So the purpose of lipid digestion is to take triglycerides and turn them into monoglycerides or glycerol backbones and single fatty acids, take phospholipids and turn them into alcohols, fatty acids, and phosphate, take cholesterol esters, turn them into cholesterol and fatty acid. Then if we're eating any waxes, which we don't talk too much about in Nutrition 101, but you could consider waxes part of lipids, they would be turned into monohydric alcohol and fatty acids. So let's talk about this lipid digestion. In the mouth, we have an enzyme called lingual lipase, which starts to digest fat, and then in the stomach, we have another enzyme that turns on called gastric lipase that continues with the digestion. However, not much can happen in the mouth or in the stomach because at that point the lipids are water insoluble, so they're just floating on top of the water. So the enzymes are in the water soluble environment down below, and the fats are in the fat soluble environment up above. And so you don't really get too much surface area for that enzyme action to work. So most of our digestion with pancreatic lipase and intestinal lipases and the phospholipases and the cholesterol esterases, all of that occurs in the small intestine. And that can occur in the small intestine after bile reacts. So we've been talking about the liver and the gallbladder since chapter 3, but we haven't actually mentioned bile because the only purpose of bile is to digest fats or emulsify fats. So the purpose of bile, and remember it's made in the liver and stored and secreted by the gallbladder, the bile is made of cholesterol and salt, and its purpose is to take the clumped fat and emulsify it, which means turn it into separated fat. So put the little droplets all throughout the small intestines. That gives more surface area, so then the enzymes, the lipases and the phospholipases and the cholesterol esterase are able to start breaking apart those fat molecules a little bit easier. So most of the action happens in the small intestine here because that's where bile is secreted into. So coconut oil is something that people always ask about. I taught you in the last class that coconut oil was a saturated fat, and I taught you that we want to avoid saturated fats. But let's just look at some fat digestive steps that occur with the long chain triglycerides, that's the LTCs, versus medium chain fatty acids, which is what coconut oil has in it. So medium chain fatty acids mean that coconut oil's fatty acids are free floating and they're a little bit shorter. So you can see these are all the steps that are taken with the long chain triglycerides. So they're hydrolyzed by lipases, so you add water to break apart the lipase. In order to do that, you really need to emulsify it by the bile. So that means taking the big clumps and turning it into smaller droplets. And then you have some facilitated diffusion to the membrane. So that means you need a protein transporter for it to cross the membrane. Then you have facilitated cytoplasmic transport, which causes you to transport through another protein a resynthesis of the triglycerides once it's inside the cell. So you need to package it back up into triglycerides. Then you pack it into a lipoprotein and secrete it into the lymph. So it's a lot of steps, right? We haven't quite gotten to what happens in the mucosal cell, but basically most of the fat that we talk about takes a little bit of, processed by proteins to transport into the mucosal cell, and then it's all packaged up into these products called lipoproteins, and then they're secreted into the lymph because the blood is a little bit too small in terms of the space in the veins to transport that fat into it. So these medium chain fatty acids are a little bit different. So they only take 2 steps to digest. So they are free floating. They're just transported across the membrane, and then they go right into the blood. So they go into the venule, the portal vein, and to the liver. So that means that we're able to use those medium chain fatty acids as energy a whole lot easier than we can use the long chain triglycerides as energy, because there's all these other steps that they need to take in order to get into the body and then circulate around the body too. So the long-chain triglycerides, as I mentioned, are packaged into these products called chylomicrons. The reason for that is lipids are hydrophobic, so they repel water. Oil and water don't mix. Oil is afraid of water, water-fearing. Blood is mostly water, right? And eventually we need those lipids to get into the blood to then be transported to cells, to be used as energy, to be used as starting material for other products, etc., etc. So the lipids need to be surrounded by hydrophilic or water-loving molecules for transport in the blood. And when we look at those hydrophilic molecules, that's going to be partly phospholipids and partly protein. Therefore, we have a lipo or lipid protein. Lipoproteins are made of triglyceride, cholesterol, phospholipid, and protein. There are 4 different kinds of lipoproteins, and they're really named for the ratio between protein versus fat, and with that fat, triglyceride, phospholipid, and cholesterol. So chylomicrons are the largest lipoproteins. They have the most triglycerides because they're packaged up right in the intestinal mucosal cells to carry fat around the body. VLDLs are what are left over after the chylomicrons have dropped some triglycerides and fatty acids off its cells. So VLDLs are a little smaller, but they still contain a pretty high proportion of triglycerides. Now, when we're fasting, we usually just see LDL and HDL in the blood. So LDL at fasting is required to bring cholesterol and drop it off to cells to use as starting materials for hormones and things like that. And then HDL is used to carry cholesterol from cells to the liver to then create bile to be secreted into the small intestine to then continue to help digest fat. And this is what these triglyceride, cholesterol, phospholipid, protein molecules look like here. So when we see what a lipoprotein looks like, they all pretty much look like this. It's phospholipids and protein on the outside, cholesterol, triglyceride on the inside. And the phospholipid fatty acids are facing towards the hydrophobic environment or the fat-loving, water-fearing environment, and the phospholipid heads and the proteins are faced outward, so then they are soluble in water. And this diagram is showing the whole process of lipid transport in the blood. So we consume some dietary fat. That dietary fat is then broken down from triglycerides, phospholipids, and cholesterol into smaller pieces that can then be absorbed. Once absorption occurs in the small intestinal mucosal cells, those are packaged back into lipoproteins called chylomicrons and secreted into the lymph. The lymph vessel then will drop that chylomicron off into the blood for an exchange, and then lipoprotein lipase starts acting, which is an enzyme that breaks down the lipoproteins, to drop some fatty acids off to body cells. And we'll talk in a little bit what those fatty acids might do in body cells. We can store them, we can use them as energy, we can use them as starting material for hormones, all sorts of things that fats do in the body. Then that lipoprotein is dropped off at the liver. Some cholesterol is released at that point to be used as bile. Then a smaller molecule called VLDL, which is another lipoprotein, is released into the blood, and lipoprotein lipase acts on that to drop some more fatty acids off at body cells. Eventually, all VLDL drops off enough of the fatty acids to then become LDL. LDL will transport around the body and bind to body cell receptors to drop cholesterol off at body cells to then be used to create different hormones and things like that in the body. HDL picks up cholesterol from those cells, brings them back to the liver to then create bile, and then bile is secreted into the small intestine to help emulsify the fat to start that process all over again. So that's how the transport is happening here. We want our HDL levels to be higher and our LDL levels to be lower, because you see that HDL kind of encourages cholesterol to leave the body, whereas LDL is kind of transporting that cholesterol all through our blood vessels, all through our arteries, and can cause a lot of damage if it becomes oxidized, which can lead to atherosclerosis, which we'll talk about in a little bit. So, thinking about it this way, LDL particles transport cholesterol from the liver to body cells, and you want to decrease your blood levels of LDL. You want the low to be low. HDL particles are going to transport cholesterol from body cells to the liver, so they can then be turned into bile and then possibly excreted from the body. So you want to increase your blood levels of HDL. You want the high to be high. Now, if you've ever gotten your cholesterol checked, what you're getting checked is your LDL and your HDL, so you're really getting your lipoprotein levels checked when you're looking at total cholesterol. So usually there's 3 values you would see on a blood lipid panel. In terms of cholesterol, it would be the LDL levels, the HDL levels, and then total cholesterol. You want your total cholesterol and LDL to be low, and then you want your HDL to be high. So there's a number of lifestyle factors that we can use to decrease LDL and increase HDL. We can 1, decrease dietary trans fat, 2, decrease saturated fat, and 3, decrease cholesterol. It looks like at this point, looking at more modern research, trans fat is the number 1 here. Saturated fat and cholesterol, although we want to decrease them, and especially from processed food sources, they don't seem to have quite as huge of an effect, especially cholesterol, on our body cholesterol as trans fat does. We also want to increase our dietary polyunsaturated fats, especially omega-3 fatty acids that are found in the walnuts, flaxseed, and fish, as well as our monounsaturated fats. We also want to quit smoking. Smoking is related to increased risk of high cholesterol and heart disease. We want to exercise. Exercise is linked to increasing HDL, or the good lipoprotein, and then improving social relationships. A decrease in overall life stress seems to also help decrease our LDL and increase our HDL. Another one that's not on here is alcohol. So it seems like people who have 1 drink a day for women, which is 5 ounces of wine, or 2 drinks a day for men, do have a slight cholesterol advantage and decreased risk for heart disease. That increases the HDL a little bit, the alcohol. However, if you're not a drinker, it's not really encouraged to start drinking, because the ill effects of alcohol outweigh the benefits, and for a lot of people it becomes addictive in nature, and you're not able to drink the alcohol in moderation as is recommended. So we're going to finish off by talking a little bit about atherosclerosis development. If we look at a normal artery should be wide open, fluid, and allow blood to flow freely through. So you can think of a trickling hose. There's lots of room, the pressure's not too much, and you're free floating through there. When we look at LDL, high LDL levels in the blood tend to become oxidized easily. When those become oxidized, they can lead to an injury in the cell. That injury in the cell with the oxidized LDL cholesterol then causes some macrophages to occur. White blood cells are going to try to come in and fix that oxidized LDL cholesterol and prevent it from harming the cell, and that results in these foam cells developing, which then start to build into plaque on the walls of the artery. That plaque embeds in the walls in the artery and enlarges, and then a fibrous cap or some scar tissue forms over it. If a blood clot comes through, that fibrous cap can rupture, and that can lead to a block in the artery. So the blood clot can block the artery, say near the heart, that could result in a heart attack, or near the brain, that could result in a stroke, or in the leg or something, and that could result in a thrombosis. So when we talk about the risk factors related to high cholesterol levels, we want our cholesterol levels to be a little bit lower to prevent the damage to the artery wall, which then leads to plaque formation and enlargement, which then could lead to plaque rupture and a heart attack or stroke or thrombosis. So that's the link between our cholesterol levels and our risk for cardiovascular disease. In addition, if this blood is flowing at a really fast pace throughout the body, that also is going to result in more injury.